Hello folks, we are again back with the next video of this exercise 6.5 question number 4 now. Luckily we have finished the question number 3 for quite some time. We were doing the question number 3. It is a big question with around 8 sub questions, each are a bit voluminous. So that's how it is. Now it is the question number 4. Let's read the question. What does it say? The question number 4 says that prove that the following functions do not have a maxima or minima. So it's kind of given in the question itself that they don't have maxima and minima. So we just have to trace out why, what is it that makes it not possible to get the maxima minima. So let's right away go for it. The first sub question is f of x is e raised to x, they say. So as usual, we'll see the first derivative and see how it goes. First derivative, second derivative, and see how it goes. So if you kind of look at the first derivative, we have learned in the previous chapter, that is chapter 5, we have learned a section on logarithmic differentiation. So there we have learnt about exponential and log functions. There it is being clearly told that the derivative of e raised to x is e raised to x, and it on investigation in that section we come to know that e raised to x can never be 0. That was given there. So if we were to make, in order to get the critical point, we generally make f dash x 0, So that's going to be our work. We generally make the f dash x 0 to get the critical point, but that's not possible here. See, let f dash x be 0, which means e raised to x is 0. The exponential function, which we have seen in the last chapter, the way the function expands, it's the way the expansion of the function is given there, it's very clear that there can be no value of x for which e raised to x can become 0. So as a result, since there is no real value of x such that e raised to x is 0, x is not existing. There is no x which can make the f dash x 0. So when there is no x existing, you will not get a maxima and minima point. Okay, so we can write here, there is no x belonging to real number or reals such that e raised to x is 0. There is no such x which will make the e raised to x 0. Its expansion is like that, 1 plus like that. So it doesn't expand it. It doesn't give you the value like that. So therefore, such that e raised to x is 0, and therefore fx, so no, there's no x. If you don't have a x, you cannot proceed at all, isn't it? So fx has no maxima minima, because to start with you are not able to get the x itself. If you get the x, then you have to check whether it is maxima or minima, but you are not able to get x, so you cannot proceed. It has no maxima or minima. Okay, so that's the result. Same way is the log. That also we have done in the last, as I told you, logarithmic differentiation. We have done exponential and log function. There we were doing this function for the first time. So we look at the expansion of the logarithmic series and the exponential series, and from that expansion it's very clear that such a thing does not exist. Okay, so that's how this happens. So here also we will go just exactly identical as we did here. Let's try to find the first derivative and see what it is. For log, we know that the derivative is 1 over x. So our next step is always going to be to get the g dash x to be 0, which means 1 over x is 0. So 1 over x is 0 means the x goes on the other side. So you will kind of get 1 equal to 0. Something like that. It really doesn't make any sense. So we can tell that therefore here x is not existing. You cannot find such a x, such that 1 over x equal to 0. It doesn't happen. So therefore is not existing. So because the x is not existing, if the x is not existing, there is no existence for maxima minima. So you can say therefore, as I told you, why it is like that, because suppose if you take the x on the other side, then you're getting like 1 equal to 0. Now that can never happen. How can you have 1 becoming, because you're taking the x on, you're taking the x on the other side. So 0 times x is 0, 1 equal to 0. I mean, just imagine. So that's not possible. So x is not existing, and therefore g of x has no maxima minima. If x is not there, there is no maxima minima. So again, this is a no maxima minima case. Yeah. Now let's go for this h of x. Let's get the first derivative here. It's going to be 3x squared. It's going to be 2x. It's going to be 1. And 1 because it's a constant not existing. Our next step is to get the h dash x equal to 0, which is 3x squared plus 2x plus 1 is 0. Now it may take us some time to factorize and get the simplification. So I think we better go in by the discriminant formula or the quadratic formula, get the answer. So maybe you can have x equal to minus b, which is minus 2 plus or minus root of b squared, which is 4, minus 4ac, 4ac over 2a, which is 6. So it's negative 2 plus or minus 4 minus 12. It's minus 8 over 6. Here is the problem. You are getting root of minus 8. That means the value of x that you are going to get, it's not a real value. Root of negative 8 is not a real value. So you don't get a real answer. We are looking out for all those values of x which are real numbers. We are working with real numbers. We want a real number. So you are not getting a real value from here. So such x doesn't exist. What is not real, we don't take that. Okay. So x is not a real number. It's not a real number. Therefore, h of x has no maxima or minimum. Just check this. Yeah, because we went on to look at that value of x in all the three cases. The x's itself were not existing. So the moment the x doesn't exist, then you really don't have any existence for the function or for maxima or for since the x is not existing, you don't have the existence for the maxima or minima. So that's going to be our logic, and this is how we are going to solve these problems. So these are excellent problems. Sometimes if it comes in the exam, you will sweat it out finding the maxima minima point, but it has to be there in your mind that no, this doesn't have a maxima minima. I have to keep that in mind and do my work. So that's about it. Quite interesting, all the three problems. With more problems. That's next. It's going to be on absolute maxima minima. We meet very soon in the next video. Thank you. As usual, all of you have to be sharing the videos to the maximum, popularize the channel, and get in more subscriptions. Thank you.